Gamma rays are a form of electromagnetic radiation. They are very unique as they have the highest frequency and the shortest wavelengths out of all the other electromagnetic waves. They are also very unique because they are considered to be soft X-rays. They have a frequency that is more than 10 to the 18 Hz and have very short wavelengths that are less than 100 pictometers, which would be 1 trillionth of a meter. These rays can be produced by 4 different nuclear reactions: nuclear fusion, nuclear fission, alpha decay, and gamma decay. Nuclear fusion is the same reaction that powers the sun and the stars. This process results in a helium nucleus. The mass difference in the helium nucleus makes up the energy that's converted. Two-thirds of that energy are gamma rays. Another way gamma rays are created is through nuclear fission, which splits a heavy nucleus into roughly 2 or more equal parts, which creates a large release in kinetic energy in the form of gamma rays. In gamma decay, the nucleus of an atom has too much energy, and as a result, it creates a gamma ray without changing the nucleus mass or composition. Alpha decay occurs when the nucleus creates a helium nucleus with an atomic number of 2 and an atomic weight of 4. This leaves the nucleus with some excess energy when it is converted into that energy, which creates a gamma ray. Also, when particles moving close to the speed of light collide with low-energy photons, these particles give the low-energy photons more energy. This turns them into high-energy photons, which are gamma rays. This process is called the Compton effect. Pulsars, black holes, and supernovas are all sources of gamma rays, but gamma rays are absorbed by the atmosphere and last about a fraction of a second up to a few minutes once a day. One theory also states that the insertion disk around black holes and compact stars might reach speeds close to the speed of light in order to create a gamma ray. Gamma rays were discovered by a French chemist named Paulville in 1900 while trying to find the radiation in radium. Then around 1963 to 1965, the US began to put satellites above the Earth to search for gamma rays. When the scientists began to search for records in the satellites, they discovered short gamma ray bursts that couldn't be produced by nuclear explosions. They also found that these short gamma ray bursts were not found within our elliptic plane, which is where the planet and all the other planets that orbit the sun are. Instead, they found that these gamma ray bursts come from other solar systems instead of our own solar system. One use for gamma rays is to kill live cells and more particularly to kill cancer cells without any difficult surgeries. Through a process called radiotherapy, healthy and cancerous cells are hit by gamma rays. The healthy cells can repair themselves very well when hit by gamma rays, but it damages rapidly dividing cells like cancer very badly. In targeted radiotherapy, the gamma ray substance is put into a certain part of the body in order to kill the cancer cells. This kills a lot of cancer cells in that part of the body, but the rest of the body does not get as much gamma ray running through it. However, risk in these procedures may cause different types of cancer and can threaten the life of unborn babies. Gamma rays are also used in the food industry. They are used to preserve foods and can kill many organisms like bacteria and yeast. Gamma rays are also used in nuclear reactors and bombs. During a gamma ray burst, not only do they emit gamma rays, but they also emit all the waves that are along the electromagnetic spectrum. Also, during a gamma ray burst, gamma rays emit a very bright afterglow. On March 2008, there was a gamma ray that was so bright that it was visible for 30 seconds. This gamma ray burst was also 7.5 billion light years away and still visible to the naked eye. Astronomers have been worried about a star called the Wolf-Rayet star. Since scientists still don't know enough about gamma rays, they don't know if this star can produce a gamma ray. If this star can produce one, the Earth will be a dangerous place to live because this star is aligned with Earth, and gamma rays can put out so much energy that they can destroy cells and alter DNA. To add to this, gamma rays are seen as the most powerful thing in our universe because they can produce even more energy than the sun. Also, gamma ray wavelengths can come to less than 10 pictometers. If a gamma ray burst has a frequency of 5.5 times 10 to the 23rd, what is the wavelength of this gamma ray burst? Alright, so unit C is the constant for all electromagnetic radiation because they travel at the speed of light. So the constant is 3.0 times 10 to the 8th power, and the frequency is given in the problem, which is 5 equals 5.5 times 10 to the 23rd. And we're trying to look for the wavelength. So the formula you can use is wavelength equals C divided by F. C being the constant and F being the frequency. So if we plug this in, we get Alright, so this comes out to about 5.5 times 10 to the negative 16th. If a gamma ray burst has a wavelength that's 2.2 times 10 to the negative 15, then what is the frequency of this gamma ray? Alright, so you already know that we have C, which is a constant for all electromagnetic radiation, because they travel at the speed of light, which is 3.0 times 10 to the 8th power, and we have the wavelength, which is given in the problem, which is 2.2 times 10 to the negative 15th. Alright, so the formula you can use to find frequency is frequency equals C divided by wavelength. C being the constant, this being the wavelength right here. Alright, so if we plug this in, alright, so this comes down to about 1.4 times 10 to the 24th power hertz.